Welcome to online lecture series, and we are discussing the reactivity of metal complexes. In earlier video we have seen the acid hydrolysis and mechanism of acid hydrolysis of metal complexes. In this video we are going to discuss the base hydrolysis. Now the replacement of one of the ligand in the octahedral complex by hydroxy group, that is OH minus, it is called as base hydrolysis, and the product of base hydrolysis is hydroxo complex. Now here actually consider the example of the pentamine chloro cobalt 3 ion. When it is treated with dilute base, then slowly there is a formation of 7 coordinated complex where cobalt is attached to 7 ligands, that is 5NH3, 1 chloride and 1 hydroxy ligand. And this 7 coordinated complex, it is highly unstable. There is a breaking of cobalt chloride bond and we get the desired product. Here overall there is a replacement of chlorine by the hydroxyl group, and here this is the example of base hydrolysis. Now in slow step there is the involvement of 2 species, that is pentamine chloro cobalt 3 ion and hydroxy ion. There is involvement of 2 species, and therefore this is the bimolecular reaction. Rate of this reaction depends upon the concentration of pentamine cobalt or pentamine chloro cobalt 3 ion and concentration of hydroxy, and this reaction follows associative SN2 mechanism. Now this reaction, it is also explained, base hydrolysis reaction is also explained on the basis of SN1CB mechanism. Now what is meaning of SN1CB? SN1CB means substitution nucleophilic unimolecular with conjugate base. There is involvement of conjugate base. Now consider the octahedral complex, that is pentamine chloro cobalt 3 ion. It acts as a Bronsted acid, and when it comes in contact with hydroxy group, that is strong base, then one of the hydrogen of this NH3, it is removed by this strong base in the form of water, and this conjugate acid or Bronsted acid, it is converted into conjugate base, that is amide chloro complex. So this is the first step. So first of all, Bronsted acid, that is the pentamine chloro cobalt 3 ion, it is converted into amide chloro complex, and this amide chloro complex gets converted into 5 coordinated amido intermediate by the loss of halogen, that is chlorine. So there is a breaking of cobalt chloro bond, this bond breaks, and by slow reaction there is a formation of 5 coordinated amido intermediate. Now this amido intermediate, it reacts with water and we get the desired product where the cobalt is attached to 6 ligands. Now from this water, OH group is directly attached to cobalt, and one of the hydrogen, it is attached to nitrogen of NH2 group, and which is converted into NH3. So overall reaction is the Cl which is attached to cobalt gets replaced by OH group, and therefore this is the example of base hydrolysis reaction. Some of the highlighting points of SN1CB mechanism are, in this SN1CB, or SN1CB stands for nucleophilic substitution nucleophilic unimolecular involving conjugate base, and this SN1CB mechanism is possible only when complex contain at least one ligand having ionizable hydrogen atom. So here NH3, in NH3 there is a ionizable hydrogen atom which can be removed by a strong base to get the conjugate base. So the complexes containing at least one ionizable hydrogen atom undergoes this SN1CB mechanism, and this is about the base hydrolysis reaction. Now last reaction, that is the Anation reaction. What do you mean by Anation reaction? The reaction of octahedral complex involving replacement of water molecule by an anion are called Anation reactions. This Anation reaction, it is a reverse of acid hydrolysis. You know that in acid hydrolysis there is a replacement of one of the ligand by water, that is aqua anion or ligand. But here, reverse to acid hydrolysis, during anation there is a replacement of water molecule from the complex by an anion. As an example, consider the reaction between pentacyano-aquo cobalt 3 ion with anion, suitable anion, that is X minus. Now this H2O, it is replaced by X minus and we get the desired product, that is pentacyano cobalt 3 ion, where this X, that is ligand, it is directly attached to cobalt. So overall reaction is water or H2O, it is replaced by anion. Now this reaction follows SN1 mechanism, that is substitution nucleophilic unimolecular mechanism. There are two steps. In step 1, there is a breaking of bond between water and cobalt. So this pentacyano aquo cobalt 3 ion slowly gets converted into pentacyano cobalt 3 ion with the loss of water molecule. So this, in second step, pentacyano cobalt 3 ion reacts with anion and there is a formation of new bond between this incoming anion or ligand with cobalt and we get the desired product. So in this way, Anation reaction follows two steps and therefore this is the substitution nucleophilic unimolecular type of mechanism. And remember, during Anation reaction there is a replacement of water molecule by an anion to get the desired product, and it is a reverse of acid hydrolysis. So in this way, here we completed the chapter, that is reactivity of metal complexes.